So the question number 3 says that let V be the real vector space. It consists of all the polynomials in one variable with real coefficients and having degree as most 6 together with the zero polynomial. Then I have to find which of this following relation holds true. So I have already given this the polynomials the having the degree at most 6. So we can write this function as this suppose this f of x is a0 plus a1x plus a2 x square. We can find that a6 x to the power 6. So we have this, we are considering two functions, this f1 and f2, and both belongs to this subspace of V. So one of the subspace condition, so whether it is this functions belong to this is a subspace of V. To prove that, we have to can get that alpha as a coefficient of f1 plus beta of f2 if it belongs to this V. We can tell this that f1 and f2 is a subspace of V. So we will go one by one. This one by one condition we will check. So let's check the first one, that is A. So we can write this f belongs to this V is f of half, which is not they belongs to the set of the rational numbers. So we can write it over like in this format: alpha f1 plus beta f2 of half. So according to the condition A, we can write it as this alpha of f1 half plus beta of f2 half. So it already mentioned that is this does not belong to this set of rational numbers. So these are all irrational numbers, this f1 and a half and f2 of half. So suppose that this is one of the irrational number, is suppose it is root over r1 and is root over r2. Okay, it's better if we just change the color of the ink. So suppose this value of f1 is r1, root over r1, and it is root over r2, and if the coefficients of this particular alpha and beta is taken as 1 by root of r1, 1 by root of r2, so it will cancel out and we will find that all the values will remain 2, right? So which is belongs to the set of this Q, right? So this is not a correct option, as you can see, because this function is a subspace of V and it belongs to the this is then if it has to be in a subspace of V, then it must belong to this particular set of rational numbers. So this is not a subspace of V, you can say that. Now go to the second condition, that is B. So here it is given the f of half, its value is given, it is 1. So we have put the same over here. It is alpha of f1 plus beta of f2 is half. So we can put it right in this way: alpha of f1 half plus beta of f2 of. So this is 1, this value is also 1, so it will go to alpha plus beta. So alpha plus beta cannot be, so if both these coefficients are 1, suppose this is also a value of 1 and this is 1, so it is 2, which is not equal to 1. So this option B is also does not belong to this, it's not a subspace of V. Okay. Now let's check the condition C. So the function of f of half is equal to this f of 1. Okay. So this we can write the same way. Alpha of f1 plus beta of f2 to half. So we can write it as alpha of f1 half and beta of f2 half. Okay. So f1 half is nothing but f1. So the same thing can be written as this alpha of f1 1 and beta of f2 1. So we can also write in the similar way alpha of f1 plus beta of f2 into 1. So from here you can see that this alpha of this particular f of half what you have is equal to this f of 1. So in this case we can see that option C is true. Okay. So let's check with the option D also. So we have given this f dash of half is equal to 1. So here you can say that this particular function, this is belongs to the subset of the subspace of V. As you can see, this both this left hand side and the right hand side are equal. Let's confirm with the option D. So we have alpha of f1 plus beta f2. So we can write it as alpha of f1 dash of plus beta of f2 dash of. Its value is 1. Okay. So it can just simply write this as 1, so it will be just alpha plus beta. Again, if the value of alpha is considered as 1 and it is also 1, so it is becoming 2, which is not equal to this 1. So the D is also not a subspace of V. So we can find that from our calculation that C is option that of this f of V. So these are assumptions. So in that case, this relation only holds true. So question 4 says that let G be a group of order 2022 and let H and K be the subgroup of G of order 337 and 674 respectively. So if H union K is also a subgroup of G, then which of the following is false? So we have the order of G, okay, is given as 2022. Order of H is 337, and order of K is 674, right? So this order of H, you can see that 337 is a prime number. Okay, so H belongs to this finite cyclic group. Okay. Just, so this belongs to this, H belongs to this finite cyclic group. So what is it? That since H is isomorphic, we can write that H will be Z of 337. Now we find this order of K. So 674 means it is 337 into 2. This order of K. Okay. So we can also write that K is as Z of 674. So what you find that H is a subgroup of this K. H is a subgroup of K. So when I find that H union of K is there, so it also belongs to this order of K, right? So H union K is nothing but the K, because since H is already a subgroup of K. From this we can also write that order of the H union K is equal to this order of K, which is the 674. Okay. So here we can find this the same thing, the order of the H union K is 674. So we can find this option in option C. So option C is correct. Okay. Let's check with the option A, that H is a normal subgroup of H union K. So we can find that from here this H is a normal subgroup of H union K. So how to find that? So we can find this from order of the H union K divided by order of H. So it is coming as 674 by 337, it is 2. So yes, we can tell that H is a normal subgroup of H union K. So option A is also correct. Option C is also correct. Okay. Let's check with the option D. So option D is telling that K is a normal subgroup of H union K. So we have already known that this H union K is nothing but this is equal to this K. So H union K is nothing but this K. So obviously this since it is very much straightforward from here, that the K is already a subgroup, a normal subgroup of H union K. So no this difficult calculation is required. So from here the option you can see easily that in our this case the order of H union K is 1011. So this if we plus this 674 and 337, it will come as 1017, which cannot be, because H is already a subgroup of K. So the two orders cannot be just summed up together to give the order of H union K. So in our case, this B option B is false. Okay.